Hello, in this video I'm going to show you how we can construct special concurrent lines in a triangle. Concurrent means that three or more lines are going to meet in a point. Okay, in this first part of the video, I'm going to see what happens when we bisect each of the angles in a triangle. So I'm going to bisect the angle at A, I'm going to put the tip of the compass on point A and draw an arc, and then where it crosses each, I'm going to each side of the triangle, I'll put the tip of the compass on one side where they cross, draw an arc, go to the other side and draw an arc, and where they cross is where I'm going to draw a line from point A, or vertex A, through that little mark right there, and there we go. And that line bisects the angle. And I'm going to do it for the other two sides. Okay, so I drew in the angle bisectors for angle B and for angle C. And you can see that the lines, the angle bisectors, all meet in a point here inside the triangle. But what's special about this point is that if we put the tip of the compass right there at the point, and we open this till it gets to the side, we can draw a circle, and this circle just touches the sides. Whoops. The circle is, oops, I moved it. But you can see that there's the circle, and the circle just touches the sides of the triangle. In other words, the sides of the triangle are tangent to the circle. The circle is completely inside, and we say that the circle is inscribed. The circle is inscribed in the triangle. So since the circle is inscribed inside the triangle, then the point of concurrency right there, that point, is called the incenter. The point is the incenter. It's the point where the three angle bisectors meet, called the incenter because it's the center of the circle that's inscribed inside the triangle. Okay, I drew in the perpendicular bisectors for segment X, Y, and side YZ, and as you can see, they all meet at this point right here. That's their point of concurrency. Now what's special about that point is that the distance from this point of concurrency to point X and the point of concurrency to point Z and point Y is the same. What that will allow us to do is if we put the compass right here, I can draw a circle around the triangle, and it circumscribes, my circle circumscribes the triangle. In other words, the circle goes around and it touches the triangle at those 4 points. So this center point right there is called the circumcenter. because it's like the circumference, it's a round, it's the outside, and then it's the center, so it's the center of the circle that will go around the triangle and touch the triangle at each of the 3 vertices. And that's what the point of concurrency of the perpendicular bisectors does. Thank you. Okay, what I'm going to do next in this triangle is I'm going to draw in the 3 medians for the triangle. So the median is going to be the point that goes from the vertex to the center, or to the midpoint of the opposite side. So to find the median at A, I need to find the midpoint of side CB. So to do that, I open the compass more than halfway, and you'll recognize it's the same construction as the perpendicular bisector, because the perpendicular bisector bisects it. Whoops. Let's do it right. Go like this, and we go like that. There we go. And then here's my line, but to keep it from getting cluttered, okay, I'm just going to draw in the median, the midpoint, and then my median is, I didn't draw this line in because I don't want to make it my picture so cluttered, but I'm going to draw in the median, which goes from A to the midpoint. So here's my median at A. Okay, and then off camera I'll do the midpoint from the median from B and from C. Okay, so what we have here is I drew in the midpoint, the median, which is from each vertex to the midpoint of the opposite side. So I used the perpendicular bisector construction, but I didn't draw in that line to make it so it wouldn't be too many lines, too confusing. So I just drew a dot for the midpoint, drew them in, and we can see that they meet right here. Now this point is called the centroid. The centroid, you think it sounds like center. Well, what it is, it actually is the center of gravity. So if I were to cut this out, it should balance. Okay, let's see. Okay, here is my triangle that I cut out from the paper. And let's see if I can balance it on the marker. And there we go. It's balanced on the marker, the tip of the marker. Okay, because it's the center of gravity. And you can do this, I mean, it's really cool if you do it with like out of wood, a piece of metal, and there it's balanced. That's the centroid, the center of gravity. Thank you. Hope you found this interesting.